Hi all. I am M.K.Nivothini, working as Assistant Professor in CEC Department, KSR College of Engineering, Tiruchendur. In today's class, we will see about Introduction to Algorithm and Flowchart. First, let us see about what is algorithm. Definition of algorithm. It is a sequence of activities to be processed for getting desired output from a given input. It can be also defined as a formula or a set of steps for solving a particular problem. It is a set of rules must be unambiguous and have a clear stopping point. According to Donald Erwin North, it has 5 properties. They are finiteness, definiteness, input, output, and effectiveness. Finiteness. An algorithm must always terminate after a finite number of steps. It means after every step, one reach closer to a solution of the problem after a finite number of steps. Algorithm reaches to an endpoint. Definiteness. Each step of an algorithm must be precisely defined. It is done by well thought out actions to be performed at each step of the algorithm. Also, the actions are defined unambiguously for each activity in the algorithm. Next one is the input. Any operations you perform need some beginning value or quantities which is associated with different activities in this operation. So, the value or quantities are given to algorithm before it begins. Next one is output. One always expects output or result, that is expected value or quantities in terms of output from an algorithm. The result may be obtained at different stages of an algorithm. If some result is from the intermediate step of the operation, then it is known as the intermediate result, and results which are obtained from the algorithm at the end is called as the end result. The output is expected value or quantities and always have a specific relations to the inputs. The last one is effectiveness. The algorithms which has to be developed or written under using basic operations. Actually, these operations should be basic so that even a principle, they can be in a principle to be done exactly and in a finite amount of time by a person using paper and pen also. An effective algorithm or a use of algorithm should have all the 5 properties. Otherwise, it will not fulfill the basic objective of solving a problem in finite time. Let us see about a simple algorithm which prints a good morning message. First, we have to start the program or start the process. Then we have to print as good morning. And then we will give the stop. Next one is the finding the area of a rectangle. First, we have to start the program. Then the inputs has to find the area of a rectangle. We need the input as length and breadth. Okay. So we have the length and breadth as the input and store them as the length L and breadth B. We have to calculate the area of a triangle. We have to multiply length and breadth, which is equal to the area. To print the area, then we will print the area. Then we have to stop the algorithm process. So to write a simple area of the rectangle, we have to get the input from the users and assign them to L length and breadth. Okay. Then we will see another example in which we will consider whether the person is eligible to vote or not. If a person's age is greater than or equal to 18, he will be eligible to vote. Else, he is not eligible. He or she is not eligible to vote. So the algorithm starts. First one, start. Then take the input as age and store it in the age component age. Okay, if then we are checking if the given input value is greater than 18, we have to print as eligible to vote. So if the age is greater than 18, we can go to the step 4. Or else if the age is less than 18, that is else part, it should be printed as not eligible to vote. If the condition is true, we have to go to the step 4. Or else if the condition is false, we have to go to the step 5. After finishing the checking, we will be stopping the algorithm. Okay. Then we will move to the flowchart part. Flowchart is the pictorial representation of an algorithm. Both the flowchart and the algorithm are independent of any programming language. We can convert that into any programming language of our choice. Okay. Then we will see about the building blocks, that is what are the symbols which are included in the flowchart. First, we will see about the basic symbols. First one is the flow line. It is called as the arrowhead. It shows the process order of operation. A line coming from one symbol and pointing to the another. Arrowheads are added if the flow is not standard top to bottom or left to right. The next symbol is a terminal symbol. Usually it is used for starting and end. That is, it describes as, it indicates the beginning and ending of a program or subprocess. Represented as a stadium, oval or rounded triangle, they usually contain the word start or end or under any phrase signaling the start or end process. And the next one is the process symbol. That is, it is a rectangle. It represents a set of operations that changes value, form or location of data. It is represented in a rectangle. Then is a diamond. It is a decision making. It shows a conditional operation which determines which one of the two or more paths the program will take. The operation is usually a yes or no question or true or false state. It is represented as a diamond symbol or as a rhombus. The next one is the parallelogram. It is usually taken for input or output. It indicates the process of inputting or outputting data, as in entering data or displaying results. And the next one is the annotation symbol, comment. It indicates the additional information about a step of the program. It is represented as an open triangle with a dashed or solid line connecting to the corresponding symbol of the flowchart. And next one is the predefined process, or it is also can be called as the function. So it describes, shows named process or function which is defined elsewhere. It is represented as a triangle with the double struct vertical edges. Next one is the on-page connector. It is a pair of labeled connectors replace long or confusing lines on a flowchart or page. It is usually represented by a small circle with a letter inside, which will be used as a twice. Okay. Next one is the off-page connector. It is a labeled connector for use when the target is on next or another page. It is represented as a home plate shaped pentagon. Next one is the storage or backup. It is a magnetic tape which is used for the secondary storage or backup. And next one is the magnetic disk symbol, which is used for storage or backup. It is a magnetic disk used for storage, secondary storage or backup. Okay, as for the advantages of flowcharts, we have seen in the previous slides the basic flowchart in pictorial form. The advantages of the flowchart are as follows. It is a communication, effective analysis, documentation of program system, efficient program maintenance, and coding of the program. First, let us see about the communication. It is a flowchart can be used as a better way of communication of the logic of a system and steps involved in the solution. Next one is effective analysis. A flowchart of a problem can be used for effective analysis of a problem. Next one is documentation of a program or system. Program flowcharts are a vital part of a good programming documentation. Program document is used for various purposes like knowing the components in the program, complexity of the program. And the next one is efficient program maintenance. Once a program is developed and becomes operational, it needs time-to-time maintenance. With the help of the flowchart, maintenance becomes easier because it is a pictorial representation. Next one is the coding of a program. Any design of a solution of a problem is finally converted into a computer program. Writing code referring the flowchart of the solution becomes easy. Then we will see about what are the limitations of the flowchart. The first one is the complexity of the logic. If the program logic is complex, then the flowchart becomes complicated. So it is easier to draw a flowchart for a simpler problems. Next one is alterations and modifications in logic. Any alterations in the program logic may require redrawing of the flowchart completely. Then the reuse is not possible. As the flowchart symbols cannot be typed, always reproduction of flowchart symbols are required. Okay. Then we will see about a simple example for a flowchart, which includes the simple interest. For the simple interest, we need P principal or rate of interest and T, time for the time period for which the interest has to be calculated. First, we will be using the terminal symbol, start and end. Okay, next is parallelogram, which is used for the input symbols. Then the rectangle indicates process. To calculate the simple interest, to calculate the simple interest, the formula is PRT by 100. Once the principal amount, rate and time period are given, we can easily calculate the simple interest SI. Once the value is calculated, it can be printed. The points to be noted are, for the start and the end, we are using the terminal symbol. Okay, it may be a rounded rectangle or oval shape. To get the input and the output processes, we will be using the symbol parallelogram. For the process, that is any calculations, we will be using the rectangle symbol. Okay. The next is to find the bigger number among the two numbers. Okay, we will consider the numbers which are given are A and B. We will first check if the A is greater than B. If A is greater than B, if it is yes, the A is big. If it is not true, then it is considered as B is big. Once the comparison is over, we will be stopping. Here, for the input, the parallelogram symbol is used. And to print which one is bigger, that is A is big or B is big, here also the parallelogram symbol is used. Okay. For the in here, that is A greater than B. For comparing, that is for decision making, we are using the diamond symbol or rhombus symbol. It will be having either yes or no. The next is to find the factorial of a number. For the factorial of a number, it is, if it is 5 factorial, the answer will be 1 into 2 into 3 into 4 into 5, which is equal to 120. It is 3 factorial, we have to give us 1 into 2 into 3. So, for the stop and start symbol, we will be using the oval. Okay, to get the input and output, we will be using the parallelogram. First, we have to initialize I is equal to 1, and the result which has to be stored is as F. So to calculate the product, we will be storing as F as 1. If we give F as 0, anything multiplied by 0 will be 0. So for that reason, we will be giving as F is equal to 1. Okay, we will be, this loop has to be calculated until n. So if n is equal to 4, we have to calculate 4 factorial, that is 1 into 2 into 3 into 4. So we will get into the flowchart, which is start and stop. The value of n will be given. Okay. So here the iteration 0 factorial is 1. So the iteration starts from 1. Next one is factorial. F is 1. So until 4, we have to repeat this loop. Okay. So first we have to increase. The input will be 1 and the value of F is 1. If the current value is less than or equal to n, if it is true, we have to calculate F is equal to F star I, that is current value. Then it will be stored in new F. For each step, that is, we have calculated 1 here. To calculate 2, it has to be incremented. So the value of I, the I value is 1. Then we are incrementing the I value to 2 here. So we have to again check. Once this step is over, that is F is equal to F star I and the I is incremented. Again, this loop will be going to the same checking symbol. Okay. The I is incremented. 2 is less than or equal to 4. Okay. If 2 is less than or equal to 4, so it is true. So again, it will come to this part. So F is equal to F star I. So already in the F, it is 1. So 1 star 2, the F will be stored as 2. Then the I is incremented. In the next steps, it will be calculated as 2 into 3, which is equal to 6. And then the next symbol is, the next number is 4. So 6 into 4, 24. So value of 4 factorial is 24. Once it have reached 4, then again we'll be incrementing and checking in the diamond symbol, which is the 4 will be, after incrementing 4, we will be getting the 5. So once it is 5, that is 5 less than or equal to 4, it is false. So we will be printing the value F. Thank you. In this class, we have seen about the algorithm and flowchart. Algorithm is a sequence of steps to find the answer or output for the given input. It is similar to a line of steps. Then next is the flowchart. In flowchart is the pictorial representation of a algorithm. Both has to be unambiguous. That is, there should be no repetitive steps. It should complete within a finite time. Both are independent of the given language. Okay. Thank you. Yes.